Good afternoon to everyone. I am Spot On Weather meteorologist Matthew Euler, and welcome to my latest video. Now, in this video today, I'm going to talk about cooler than normal Augusts and the following winters. All right, so why was I motivated to create such a video, you may ask? Simply because it's been quite a below normal temperature month here across Southeast Virginia and specifically across parts of the Mid-Atlantic. Um, for example, the Norfolk International Airport for August of 2025 was 3.4 degrees Fahrenheit below normal. The mean temperature was 3.4 degrees Fahrenheit below normal for the month of August. Additionally, the Norfolk International Airport only saw two 90-degree plus days when the average is 9. There's normally 9 90-degree plus days for the month of August for the Norfolk, Virginia area. And so it's not just here in the Norfolk area, but other parts of the Mid-Atlantic, such as Baltimore, Maryland, Washington, D.C., other areas have also experienced, Richmond, Virginia is another one. These areas have also experienced cooler than average Augusts. So my overall sense, whenever I see this abnormal weather set up, I want to go ahead and examine and see what the following winter season would hold. So I hope you enjoyed the presentation. Let's go ahead and kick things off. Again, the purpose really of this video is to examine if there is a linkable connection between cooler than average Augusts and the following winter temperature and precipitation anomalies. So not only will we look at the following winter temp anomalies, but we'll also look at the precip anomalies. Now, what I'm showing you here in the bottom right is just an example of the abnormal cool air that we've seen recently. Any of these blue and green dots indicate either tide or new record low temperatures. This was back on the morning of the 27th of August, 2025. And you notice these dots extend pretty far south for late August. Those in the Birmingham area, as well as those over towards Atlanta, Georgia. In fact, Atlanta, Georgia set the all-time coolest temperature for the month of August at 55 degrees on the 27th of August 2025. But we had 115 either tied or broken new record low temperatures on this particular morning. All right, so the overview here, since 1981, there have been 15 cooler than average Augusts across the Mid-Atlantic. So if we look back to 1981 from the present time, we're looking at 44 years of data, and only 15 of those 44 years equals about 34% of the time we've seen August cooler than average. So it's one in every three, almost 1/3 percentage there, but it doesn't happen as frequent as we may suspect. In fact, August is typically still, pretty hot and muggy across the area. Now, in August of 2025, again, Hampton Roads, Virginia cities, and this is now official. These cities, the Hampton Roads area, saw just two 90-degree plus days, and is generally finished overall for the below the mean temperature value of 3.4 degrees below normal. Now, when the weather is unusual, again, I really think when the weather is unusual, that's the best opportunity to examine what the following season holds. So I decided to say, you know what, this is a kind of abnormal, we're talking about dew points into the 50s in late August, highly unusual for the area. So in general, I went ahead and took a look at the following winters. So the agenda, the first thing we'll do today is we'll look at cooler than average August years. Then we'll look at the temperature anomalies during the following winter seasons, plus the ENSO, El Nino Southern Oscillation phase. We'll then examine the precipitation anomalies during the following winter seasons, plus the El Nino Southern Oscillation phase. And then I'll look into other teleconnections during those following winter seasons after cooler than normal Augusts. And then we'll take a look ahead here at the ENSO forecast for the upcoming 25-26 winter season, and then I'll conclude. All right, so let's start off with the years that feature cooler than average Augusts. These following charts are courtesy of Prism Climate Group, Oregon State University, and any of the blue and green colors indicate below normal temperatures. Any of the orange coloring indicates above normal temperatures. And by the way, we're comparing these temperatures to the 1991 to 2020 historical climatology data set. So we'll start off with 1981 here on the left, and you can clearly see it was cooler than average, really from eastern Colorado down to New Mexico, east across the Midwest. The southern plains was below normal in 1981 in the month of August. And then along the mid-Atlantic, you see temperatures were generally about 3 to 4 degrees below normal in August of 1981. Over here on the right is August of 1982, and you can see the coolest readings are in green. The coolest departures from normal up into Pennsylvania, New York State, Vermont, New Hampshire, and Maine. The blue coloring here indicating about 2 to 3 degrees Fahrenheit below normal across southeastern Virginia and much of the state of Virginia. 1985 on the left here showing again, slightly below normal temperatures, about 1 degree to 2 degree Fahrenheit below normal across Virginia, extending southward into the Carolinas in August of 1985, and even up northward here into New England. The coolest of normal air in the green coloring again across the northern plains in 1985. We have North Dakota, Montana, Idaho, and eastern Oregon. On the right, we're showing the cooler than average August of 1986, and we see the Midwest really have the coolest temperature departures. We're talking 4 to 5 degrees below normal across northern Missouri, Iowa, and southern Wisconsin, about 4 degrees below normal across northern Illinois and Minnesota and Wisconsin. It still was below normal, however, across the mid-Atlantic from Virginia northward to Maryland, Pennsylvania, New Jersey, northward into New England in 1986. August 1989 here on the left, and much of the country had blue shading for August of 89, indicating below normal temperatures, specifically in the mid-Atlantic, about 1 to 2 degrees Fahrenheit below average from the mean temperature for August of 1989. That extended northward 1 to 2 degrees Fahrenheit below normal into New York State, up towards Maine and Massachusetts. The coolest departures from normal, though, in August 1989 were across the western U.S., Idaho, western Montana, parts of Washington State, much of Oregon running 4 degrees to 5 degrees below normal, and then Northern California and Nevada. Over here on the right, we're now going to August of 1992, and you notice the cooler than normal readings for August of 92 went all the way from the U.S.-Canadian border down into Texas. In fact, North Texas was averaging 5 to 7 degrees Fahrenheit below normal, 7 degrees below normal across Oklahoma, including Oklahoma City, and Kansas as well. Nebraska was running 4 to 6 degrees Fahrenheit below normal, as well as South Dakota. Missouri running 6 to 7 degrees below normal. And you see this blue coloring here along the mid-Atlantic, anywhere from 3 to 4 degrees Fahrenheit below normal in Virginia, up towards Maryland. We look at August 1994 here on the left. Again, much of the U.S., generally east of the Rocky Mountains, was running below normal. For parts of Virginia, 1 to as much as 4 degrees below normal across the state. So all the blue coloring, again, much below normal across the east. That peach color here indicates above normal readings across the Intermountain West in August of 94, and it was slightly below normal temperature-wise across the Pacific Northwest. Over here on the right, we're showing August of 96, showing 3 to 4 degree Fahrenheit below normal departures across southeastern Virginia, all the way down to the Carolinas, 1 to 2 below normal degrees there across Georgia, and then below normal across Oklahoma and North Texas. And this is Wow, okay, that's not correct. And I apologize for this, but 1997 was also cooler than normal. But unfortunately, when I was saving the slides, this is showing you December of 1997 here on the left. So sorry about that. But I can assure you that the Mid-Atlantic was once again below normal for August of 97. Wow, I don't know why I did that, but there I did it. Um, Actually, it was August of 1996 is what it should be. So this should be 1996, and that should be the year 2000. So I apologize for this graphic on the left here, but it was running about 1 to 2 degrees Fahrenheit below normal in August of 96 across mid-Atlantic. Over here on the right, we're back to August where we should be. Now we're looking back at August of 2000, which shows generally 2 to 3 degrees Fahrenheit below normal for the mean temperature across the mid-Atlantic, Virginia, Maryland, 1 to 2 degrees below normal across Pennsylvania, 2 to 3 below normal there across Ohio, and the cool air extended all the way up towards Massachusetts and Connecticut and Rhode Island. Over here on the left, we have August of 2004. Notice the green colors again, indicating the greatest below normal readings, anywhere from 4 as to much as 7 degrees below normal in the green coloring here from the southern plains up to the Missouri River Valley, into the Midwest, Iowa, Illinois, Wisconsin, Minnesota, and the Dakotas. And that was slightly below normal, about 1 to 2 degrees, in some cases 3 degrees Fahrenheit below normal across the interior portions of North Carolina in August of 2004. Over here on the right, we're showing you August 2008. Notice the theme again, below normal, generally from Western Virginia, the West Virginia area, Eastern Ohio to Pennsylvania, New York State, up to New England. Right immediately here in Hampton Roads is kind of like on the borderline between running 1 degree below normal and near average. Over here on the left, on the next slide, we have August of 2013. And notice again how below normal we're running, 2 to 3 degrees Fahrenheit below normal across the state of Virginia, 1 to 2 degrees below normal there across the Carolinas, 2 to 3 degrees below normal across northern Alabama and northern Georgia in August of 2013. And the cool air expanded westward towards southern Missouri and eastern Kansas. Over here on the right, we show August of 2014. And again, look what we got August of 2014 here. We have generally 2 to as much as 4 degrees Fahrenheit below normal from the mean temperature in August of 2014, and below normal across Pennsylvania, New York State, up into southern New England. We also had a pretty significant below normal area across the desert Southwest in August of 2014. And that may have been more influenced by the monsoonal moisture and the increase in cloud cover during that time of year, more of the rain out that way. And then finally, the 15th and final August, which was below normal since 1981, was August of 2017. Which generally what you're seeing is a concentration in green there of the coolest temperature readings across parts of central Missouri into eastern Kansas, where temperatures are running 4 to 5 degrees below normal. And generally, you see the central U.S. in the blue coloring here. Anywhere from 2 to 3, sometimes 4 degrees Fahrenheit below normal in this central U.S. area, and generally about 1 degree below average for Hampton Roads, 2 to 3 below normal across southern Pennsylvania, and then up towards Maine, 1 to 2 degrees Fahrenheit below normal. The warmest readings in August 2017 over the Pacific Northwest, which is quite similar to what we've been seeing this past August. We saw a lot of above normal readings across Washington State and Oregon recently. All right, so now let's examine the following winter temperature anomalies. Let's look at first, after these cooler than normal August, let's look at the following winter. So we'll start with the 81, 82 winter temperature anomalies. Anytime you see green, blue, dark blue, that indicates below normal temperatures. Whenever you see the oranges, specifically these brighter oranges, that indicates pretty mild temperatures, well above normal. Whenever you see the white on these charts produced by the NOAA Physical Science Laboratory, if you see white coloring, that indicates near average temperatures. All right, so let's continue here. December 82. So when I talk about the winter temp anomalies, I'm talking from December 1st to the end of February, meteorological winter. And you see it was a cold winter across the northern plains, the winter of 81, 82, right on down into the Midwest. That was where the bulk of the coldest temperatures resided that winter. But let's not count out these aqua color here across the mid-Atlantic, from Virginia northward to Delaware and Maryland and New Jersey and Pennsylvania to Washington or New York State and Connecticut, Rhode Island, Massachusetts, right up to Maine. So it was a below normal temperature regime from the mid-Atlantic to New England, but really from the Midwest to the Northern Plains. And by the way, 1981-82 winter featured neutral ENSO conditions. On the right here, we're showing the winter of 82-83. Generally, you're seeing the orange coloring across the northern plains, so much above normal temperatures from northern Illinois, Wisconsin, lower Michigan, Minnesota, eastern Iowa, up into the Dakotas, where it was really above normal, as well as eastern Montana. So those are milder areas. By the way, in the white coloring, remember, when it's white, it's near average. So mainly near average across the mid-Atlantic overall. And then the cooler than normal readings were associated down here across West Texas and into New Mexico. By the way, the 82-83 winter season was El Nino winter. On the left here, we're looking at the winter of 85-86. And notice again, wow, this deeper blue coloring for those of you living in eastern Minnesota, Wisconsin, eastern Iowa, into northern Illinois had the greatest, in excess of 6 degrees Fahrenheit, departures from normal for the winter. So it was quite a cold winter across the upper Midwest. It also was pretty cold across parts of the Southeast down to Alabama, into Tennessee, Kentucky, Virginia, parts of North Dakota, northward. Another area which was running 4 to 5 degrees below normal across eastern Pennsylvania, New York City, Boston, right on down to D.C. area. By the way, the 85-86 winter season featured neutral ENSO conditions. So when I say neutral, not an El Nino, not a La Nina. Over here on the right, the winter of 86-87, showing above normal temperatures again across the northern plains. Yeah, 86-87 was a warm-up up in the Dakotas and Minnesota, specifically in Iowa. The aqua coloring cooler than normal there from the Georgia area through the Carolinas up to Virginia and to parts of eastern, southeastern Pennsylvania, right up into New England, up toward Maine. And also was below normal along the Gulf Coast areas here, the southern areas of the U.S. Not surprisingly, it was El Nino winter, and this is typically what you get. You notice the 82-83 El Nino was a very strong one, and this is the general pattern. You get warmer or above normal temps in the winter across the northern U.S. and cooler than normal temps across the southern U.S. The storm track is more active across the southern U.S. in El Nino winters. So you're seeing similarities here. Two El Nino winters, 82-83 on the right, with temp anomalies, and then 86-87 over here on the right. Looking at 89-90 winter temperature anomalies, let's take a look at that. Kind of a mixed bag. You know, you had above normal temperatures across eastern Montana and the Dakotas, in the parts of Minnesota and Iowa and west central Illinois. You had above normal temperatures that winter across southern Georgia, northern Georgia, parts of South Carolina, and parts of inland North Carolina. And you had below normal readings across the far portions of northern New England, Vermont, New Hampshire, and Maine. And then over in the desert southwest areas, Arizona and specifically New Mexico, as well as parts of California in the winter of 89-90 were below normal. Over here on the right, we're showing you, by the way, the 89-90 winter season featured a neutral ENSO. Over here on the far right, we've got the 92-93 winter season, near average winter temperatures across the mid-Atlantic, below normal across northern New England again, up toward Maine and parts of Vermont, New Hampshire, and Massachusetts, and as well as Connecticut and Rhode Island. And then really the bulk of the coldest air that winter in the 92-93 season was back towards Nebraska, western Kansas, western South Dakota, parts of North Dakota, as well below normal across Montana, eastern and most of Wyoming actually, and then also across interior Pacific Northwest areas and northern Nevada. And the 92-93 winter featured a neutral ENSO. 94-95 winter season here on the left. Temperature anomalies. Notice well above normal across the western U.S. This is incredible. A very warm winter across Colorado, western Kansas, Nebraska, western South Dakota, eastern Montana down to Wyoming, southern Idaho, parts of Nevada. And it was below normal generally from Florida northward into South Georgia and portions of the Carolinas. It was also above normal across New England in the winter of 94, 95. And by the way, it was El Nino winter. So a little bit different temperature anomaly composites here for this El Nino winter. Very warm across the western U.S., not just the northern U.S. that you'd expect, but across much of the western U.S. Over here on the right, we're looking at the winter of 96, 97, showing above normal temperatures generally across the mid-Atlantic up towards New England. And the bulk of the colder than normal temperatures were in the blue here across the Dakotas in the winter of 96, 97, as well as the parts of southwestern Texas. And notice it was a neutral ENSO in the winter of 96, 97. 97, 98 here on the left. Back to El Nino. Very strong El Nino winter. And I mean, if you were to compare 97, 98 over here on the left to 82, 83, both were strong El Ninos. Look where the warmer temperature anomaly set up. Midwest to the northern U.S., right there up to the Canadian border. And sure enough, 96 or 97, 98 set up the same exact way. Look at this. Look at this. Well above normal temperatures across, especially northern Minnesota, Dakotas, parts of Wisconsin, Iowa, Illinois, other parts of Michigan there, Indiana, Ohio, Pennsylvania, New York State, well above normal temps. And those slightly above normal temps extended down towards Virginia. Over here on the right, we're showing the winter of 2000, 2001, which was a La Nina winter. And much of the U.S. was below normal that winter, the 2001 winter season, but the bulk of the coldest air is in the blue here across Minnesota, eastern South Dakota, eastern Nebraska, central and eastern Kansas, down to eastern portions of Oklahoma. Even North Texas was below normal. Look how far the blue extends all the way down to northern Louisiana and northern Mississippi. For you in Memphis, you were running below normal in that winter of 2000, 2001. Even the aqua colors here, this is 1 to 2 degrees Fahrenheit below normal for the winter season. Not as cold as parts further west, but still colder than normal nonetheless. If we look at the winter of 2004-05 on the left, this is El Nino winter. Look how above normal much of the United States was in the winter of 04-05. We're talking the warmest anomalies across South Dakota, parts of Montana, Wyoming, Colorado, eastern Utah, right on down into Arizona, New Mexico areas, and Texas. You also are in that. The only cool spots, cooler than normal temps, were across New England, New York State to Maine, and South Florida, and that was it. Over here on the right, we show the winter 08, 09, showing below normal temperature readings across the northern U.S., upper Great Lakes area, Wisconsin included, upper Michigan. And then we have warmer than normal readings of the yellows and the oranges across Colorado, western Kansas, western parts of Oklahoma, all of Texas, southern Louisiana, Mississippi, and Alabama. Moving on now, and that, by the way, that was a La Nina winter, the 08-09 winter. 04-05 was El Nino here on the left. Moving on, at the 13-14 winter season, it was neutral ENSO conditions, so neither La Nina or El Nino that winter. Well below normal temperature readings across Minnesota, Wisconsin, Michigan, as well as northern Illinois, eastern Iowa. That was the bullseye of the coldest temperatures of the winter. But we still are running up to 3 degrees Fahrenheit below normal across the Carolinas, up to Virginia, and even colder up towards Pennsylvania, New York State, Massachusetts, and Connecticut, as well as Rhode Island and southern Vermont and New Hampshire. The only warm readings for that winter of 13-14 were out over the California area, Nevada, as well as New Mexico. And on the right here, we're showing the winter of 2014-15, which was an El Nino winter. Look how above normal temperatures were the winter of 14-15 across the western U.S. And then look how below normal these blue colors were across the eastern U.S., specifically east of the Mississippi River, right to the east coast up to New England. Well below normal temperature readings. We're talking the darker blues representing up to 5 to 6 degrees Fahrenheit below normal temperatures in the winter of 14-15. And then finally, the winter temperature anomalies from the winter season 2017-18. It was a La Nina winter in the 17-18 winter. Near average temperatures are in the white color across the mid-Atlantic up to New England. But we had above normal temperature readings across the Carolinas, Georgia, South Alabama, as well as Florida. Central Florida specifically averaged up to 4 degrees Fahrenheit above normal that winter. So it was a mild one for you living in Central Florida, Orlando, right on down towards Tampa. And then over here, look at this. I mean, where my red dot is across Montana, Dakotas, Nebraska, as well as Minnesota, below normal temperatures for that winter season, 17-18 winter. And then the desert Southwest was much above normal. Now let's examine the winter precipitation anomalies after cooler than normal August. So starting with the 81-82 winter on the left, and you see the values here with the legends under each of the images. So if you have aqua colors or light blues to dark blues, that's above normal precip. If you have yellows and oranges, that's below normal precip. So we start off with 81-82 winter, and by the way, the white coloring indicates near average precip for the winter. All right, so below normal precipitation, 81-82 winter for Hampton Roads area, Southeast Virginia down towards the Carolinas, into northern and central Georgia, as well as central and southern Alabama, and the Florida Panhandle. You were running above normal in that winter for precip. Below normal across northeastern Texas, down into Arkansas, as well as Louisiana and the northwestern corner of Mississippi. Also an above normal precipitation winter across the Pacific Northwest. You got a lot of rain or a lot of precip, snow in the higher elevations in Washington State, down the coast there, down Interstate 5 into Oregon. Over on the right, we're showing precipitation, winter precip anomalies for the winter of 82-83. A very dry winter from Ohio, Pennsylvania, West Virginia, into the western portion of Virginia, up towards D.C., Pennsylvania, New Jersey, New York State, up toward Maine, below normal in the yellow, and above normal across the deep south. And again, I do have, what the winter featured as far as the ENSO phase. El Nino winters typically have a wetter than normal pattern from Southern California, more active subtropical jet stream, so above normal precip, Southern California, into Arizona, New Mexico, South Texas, Louisiana, Florida Panhandle area. This is usually above normal areas in El Nino winters, and then drier than normal to the north. Now, the 85-86 winters on the left showing well below normal precip in the darker orange. We're talking running 11 inches below normal, up to 11 inches below normal in Mississippi, down towards Louisiana in this particular winter, the 85-86 winter. And it was drier than normal all the way up into North Carolina as well as Virginia. Also well below normal precip across coastal Washington State. Above normal precip across North Florida and the parts of northern and central California, as well as parts of Oregon, Idaho, and western Wyoming. The winter of 86-87 here on the right, it was a very dry winter season from Southern California all the way up the west coast there to Washington State, including you in Seattle. Also well below normal precip across Idaho into parts of Montana. It was drier than normal for you living in the Midwest, from eastern Iowa and Illinois, eastern Missouri, well below normal there, quite significantly below normal across southern Indiana, and then drier than normal all the way up towards New England, towards Maine. It was wetter than normal in the El Nino winter of 86-87 for southeastern Virginia, Delaware, D.C., southward to the Carolinas and parts of Georgia, as well as Florida. And right along that Interstate 10 corridor, it was above normal from Houston, Beaumont, Port Arthur area, right on through to New Orleans, Mobile, Biloxi, Tallahassee, Pensacola, running above normal that winter. 89-90 winter season, much of the United States was in the white coloring, indicating near average precip during this neutral ENSO winter. So you see well below normal anomaly across Northern California at 89-90 winter. Above normal precipitation there, Louisiana, Mississippi, Alabama, towards northern Georgia. Over here on the right, we're showing 92-93 winter season precip anomalies for the winter season. Neutral ENSO, we have well below normal precip across very dry conditions across the coastal portions of Washington State, but above normal across California for precip, above normal in Arizona as well. A lot of the mid-Atlantic near average for the winter of 92-93. Looking at 94-95 winter precip anomalies here on the left, showing above normal precip for the winter across California, parts of southern Arizona, above normal in eastern Texas for precip, as well as parts of the coastal Carolinas there, from North Carolina down to South Carolina, as well as coastal Georgia. It was slightly below normal for precip that winter of 94-95 for Hampton Roads over to Richmond, Virginia, and right on up towards Dover, Delaware, and parts of southern New Jersey. Over here on the right, showing the 96-97 winter precip anomalies. Much of the nation was near average in the white coloring here. We did have above normal winter precip anomalies across the western U.S. that winter. The 97-98 winter season with the El Nino, strong El Nino, a typical El Nino looking pattern here, wetter than normal winter across California through southern Arizona, through Texas, Louisiana, Mississippi, Alabama, and Georgia. Well above normal precip anomalies there, way wetter than average across central and northern Florida, on up towards the Carolinas into Virginia. And then over on the right, we're showing the La Nina winter of 2000-2001, and well below normal. Very dry conditions that winter across portions of western Washington state there along the coast down to Oregon, as well as parts of northern California north of the San Francisco Bay. Well below normal, very dry. The La Nina winter of 2000-2001 along the immediate Gulf Coast. Florida is included in that, as well as a lot of drier than normal conditions in the mid-Atlantic, including those of you in Virginia. The 04-05 winter, this should be precip anomalies, not temperature anomalies. That is a typo there. This is winter precip anomalies. The 04-05 winter here on the left, showing drier than normal conditions across the Pacific Northwest, Washington to Oregon, coastal sections. Well above normal precip across Southern California from LA down to San Diego. Above normal precip in the 04-05 winter season into Arizona, as well as parts of New Mexico. Drier than normal in this El Nino, which is kind of oddity here. This is El Nino winter of 04-05. And usually these areas that are yellow, the Gulf Coast to the mid-Atlantic, are usually above normal. So something else was really, really dominant that winter as far as the teleconnections go. Over here on the right, we're showing the February 08, I'm sorry, not February, the winter of 08-09 precip anomalies, very dry along the U.S. West Coast from Washington State down to Northern California, very dry across eastern Texas into parts of southeastern Oklahoma, southwestern Arkansas, and almost all of Louisiana had a very dry winter, 08-09 winter season, as well as parts of southern Georgia up to coastal Carolinas. Drier than normal as well across parts of southeastern Virginia. It was wetter than normal across the Midwest, northern Illinois, and Michigan, as well as northern and central Indiana, parts of Ohio, Kentucky as well, West Virginia as well. The 2013-14 winter precip anomalies on the left, this neutral ENSO winter, drier than normal along the immediate west coast from Washington State down to California, drier than normal in Arizona, and then drier than normal across eastern Texas into Louisiana, extending northward, drier than normal into eastern Kansas as well as southern Missouri. But this neutral ENSO winter of 2013-14 featured above normal precip across Virginia, portions of northern North Carolina. Georgia was included in that, western South Carolina, northern Indiana, eastern Kentucky, West Virginia, up towards southeastern PA, as well as New Jersey. On the right, showing the winter precip anomalies for 2014-15 winter season. Look how dry that winter was across the Midwest, right on down to the Ohio River Valley. Kentucky, very dry winter. Western portions of North Carolina, very dry winter. Portions of Arkansas, northern Mississippi, parts of Louisiana, all the way up to Wisconsin and Michigan, specifically the lower portion of Michigan, as well as Pennsylvania and New York State, well below normal. Now, along the immediate coast here, the North Carolina and South Carolina area, as well as southern Georgia, we did have an above normal precip for that winter. Also across the areas from Massachusetts, including you Boston, working northward toward Maine, were above normal in precip. Finally, the winter precip anomalies for the 2017-18 winter season, very dry on the western coast again. Oregon down, Northern California that winter was exceptionally dry. We're talking 13 to 14 to 15 inches below normal of precipitation for that winter across Northern California. It was drier than normal, but not as extremely dry as normal. There across southern Alabama into central Georgia and the coastal portions of South Carolina. A lot of the U.S. was near average in the white coloring here in the winter of 1718. And that was a La Nina winter. All right, so just to summarize all the graphics and the breakdowns I just showed you, the winter temperature and precip, I basically grouped it together after looking at all the graphics we just looked at. And let's look at the following winters after cooler than average Augusts. 81, 82 winter season, and I'm focused on the mid-Atlantic here. And that's what I'm using as my comparison tool. So 81, 82 winter season, the mid-Atlantic had colder and wetter than normal conditions. 82, 83 winter season, across the mid-Atlantic, we had near average for both the temps and precipitation. The 85, 86 winter season, we had colder and drier than normal weather across the mid-Atlantic. The 86, 87 winter season was colder and wetter than normal. The 89-90 season, near average for both the temperatures and the precip across the mid-Atlantic. The 92-93 winter season, we had near average for both the temps and the precipitation. 94-95 winter season, slightly above average temperatures and drier than normal precipitation for the mid-Atlantic. And then the 96-97 winter season, we had above average temperatures with near average precipitation. 97-98 winter season, above average temperatures and wetter than average precipitation during that strong El Nino. That's not really a shock there with the wetter than normal precip or wetter than average conditions for the mid-Atlantic. 2000-2001 winter season, below average for both temps and precip. So that was a cold and drier winter for the mid-Atlantic. 04-05 winter season, we had near average temperatures with below average precip. 08-09 winter, we had near average temperatures and below average precip again. And then 2013-14 winter season, we had below average temperatures with above average precip. So if you were looking for a nice winter season across the mid-Atlantic, this was your winter, 13-14. And then 14-15 winter also was colder than normal. So we had back-to-back years in which we feature below normal temps across the mid-Atlantic. Now, 14-15, we were near normal or near average for precip. And then 2017-18 winter, we had near average temperatures and near average precip. So conditions coming in relatively close to normal for the mid-Atlantic in that particular winter season. All right, so now let's just analyze this. Let's just take cooler than average Augusts plus the ENSO phase into consideration. Just those two. I'm not looking at any other teleconnections here. Just the cooler than average August and the ENSO phase the following winter. Okay? 7 of those 15 winters. Now remember, I said there were 15 cooler than average Augusts, right? Going back to 1981. So the following winters, 7 of those 15 winters following the cooler than average August featured near average temps. 6 of the 15 following winters featured below average temperatures. And this one gets me the most. It really stands out. Only two of 15 of those 15 following winters, about 13%. Only 2 of those 15 following winters after cooler than average August featured above average temps. That's it. Now, 6 of the 15 winters feature near average precipitation. 5 of the 15 following winters featured below average precipitation. And then 4 of the 15 winters featured above average precipitation. So there's not a big difference in this data as far as the precipitation departures as there is with the temperature departures. So, if we look at just cooler than average Augusts and the following winters, you see 7 of those 15 following winters near average temps for the winter, 6 of the 15 below average. So it's really close here, 7 and 6, right? But what really stands out again, cooler than average August following winter, only 2 of the 15 winters, just 13% of those winters featured above average temperatures. All right, so then after I just took a look at the cooler than average August plus the ENSO phases, I then went and looked at other teleconnections the following winters. Okay. All right. 1981-82 winter season, we had a negative AO in December. Then, actually, December and January, there was a negative Arctic oscillation. And then it went positive in late winter into February, the AO. We had a neutral NAO in the winter of 81-82 in December. Then we had a negative NAO in January, and then a positive NAO in February of 82. So NAO was kind of all over the place. The 81-82 winter, it featured anything from a neutral to a negative to a positive. Now, we did have an easterly quasi-biennial oscillation, easterly QBO. We had a negative Pacific North American pattern, and we had a weaker disrupted stratospheric polar vortex. So SPV, whenever you see those initials, is stratospheric polar vortex. There actually was a sudden stratospheric warming in January of 1982, by the way, that winter. And whenever I see the bold colors here with the QBO and the SPV, the stratospheric polar vortex, it's just generally showing you the relationship. Easterly QBOs generally are associated with weaker, more disrupted stratospheric polar vortexes in the winter. The 82-83 winter season featured a positive AO or Arctic oscillation in December and January, turning to a negative AO in February. The 82-83 winter had a positive NAO in December and January, with a negative NAO in February. Now, 82-83 winter season featured a westerly QBO, a positive PNA, Pacific North American pattern, and a stratospheric polar vortex, SPV, weaker than usual. 85-86 winter season featured a negative AO, positive NAO in December and January, a negative NAO in February of 86, a westerly QBO, a positive PNA, a stratospheric polar vortex was stronger in December, then weakened and stretched in January. The 1986-87 winter season featured a neutral AO in December, becoming negative, the AO in January and February of 87, positive NAO in December, turning negative to negative side of the NAO in January and February, featured an easterly QBO along with a positive PNA and a weaker stratospheric polar vortex. The 1989-90 winter season featured a negative AO in December, a positive AO in January and February, a negative NAO in December, a positive NAO in January and February, easterly QBO, positive PNA in December, negative PNA with troughing in the western U.S. in January and February. And 89-90 winter season was also known for an exceptionally strong stratospheric polar vortex. 92-93 winter season, positive AO in December and January, turning neutral, the AO turning neutral in February of 93, positive NAO overall throughout the whole winter. Westerly QBO, a negative PNA in December and January, so that would feature the trough in the western U.S., coldest air in the west, and warmest and mildest temperatures with the ridge in the east. Then it turned positive, the PNA, in February of 93, but the winter of 92-93 featured a strong stratospheric polar vortex. The 94-95 winter season featured a positive AO in December, negative AO in January, positive AO again, though, in February. Positive NAO in the winter of 94-95 with a westerly QBO, a positive PNA, and then a weaker stratospheric polar vortex in mid to late January. That would be January of 95. 96-97 winter season featured a negative AO in December and January, turning positive in February, a negative NAO in December, January, becoming positive in February, an easterly QBO, a negative PNA, the trough in the western U.S. and the ridge in the east in December, becoming positive PNA. So now we've got the ridge in the west and the trough in the east in January and February. And we did see a weakening of the stratospheric polar vortex in late December of 96. Turning to 97-98 winter season, neutral AO in December, becoming negative in January and February. A negative NAO in December, becoming positive NAO in January, then a neutral NAO in February. We did see a westerly QBO along with that very strong El Nino winter there of 97-98, plus a positive PNA with a weakening stratospheric polar vortex in mid to late December. 2001 winter season featured a negative AO throughout the winter. This was a very cold winter for the East. So it's no shock we have a negative AO. That's usually colder, indicates colder temps in the East. A negative NAO in December became positive in January and February. But the 2001 winter featured easterly QBO, a positive PNA with the ridge in the west and the trough in the east in December and January. It did flip to where we got a negative PNA in February, where the trough went to the western U.S. and the ridge in the east. And we featured that winter, it was a weaker stratospheric polar vortex. The 04-05 winter season featured a positive AO in December and January, becoming negative in February. A positive NAO in December, January, becoming neutral, the neutral NAO in February. Westerly QBO in 04-05 winter season, positive PNA in December, then a neutral PNA in January and February. A very strong stratospheric polar vortex in late December, early January, weakened late January and February. The 08-09 winter season featured a positive AO throughout the winter, right up until February. Then it went negative AO in February. Negative NAO in December became neutral NAO in January and February. The 08-09 winter featured a westerly QBO, a negative PNA in December, becoming positive PNA in January, but then going right back to negative PNA in February. And there was significant stratospheric polar vortex weakening in January of 09. The 2013-14 winter season featured a positive AO in December, but that transitioned to a negative AO in January and February, right in the heart to late portions of the winter. Positive NAO throughout the 13-14 winter season. No, I didn't really examine the MJO, so we'll leave that out for now. But there was a westerly QBO in the winter of 13-14. We had a negative PNA in December, a positive PNA in January, and a negative PNA in February. And 13-14 winter featured a strong stratospheric polar vortex in early to middle December, weakening in late January and middle February. And then the 14-15 winter season featured a positive AO throughout the winter, positive NAO, but it did feature an easterly QBO, which does favor that weaker than average stratospheric polar vortex. And that happened in middle December to late January of 2015. Positive PNA throughout the winter of 14-15. And then finally, the 17-18 winter season featured a neutral AO in December and a negative AO in January, back to positive AO in February. The winter of 17-18 featured a positive NAO, easterly QBO, positive PNA through December and January, turning negative the PNA February, and a weaker stratospheric polar vortex in early December, followed by strengthening, and then another phase of weakening of the stratospheric polar vortex in late January and early February. All right, so we did a lot of, I wanted to just show you, in addition to the cooler than average August and the following winters, in addition to just looking at cooler than average Augusts, as well as the El Nino Southern Oscillation phase, whether it was El Nino, La Nina, or neutral ENSO that winter, following these cooler than normal Augusts, I wanted to show you there's a lot more involved. It's not just simply looking at, hey, it's a cooler than normal August. Oh, that must mean we're going to have a bad winter. No, that's not the case. Or, hey, look at this, the following winter back in 96-97 had a neutral ENSO. It followed a cooler than average August, so 25-26 winter should end up the same, right? No. I wanted to show you that the atmosphere-ocean interaction is a lot more complex than we give it credit for sometimes. And all these different teleconnections, they all mean different things, from the Arctic Oscillation in the winter to the North Atlantic Oscillation in the winter to the QBO phase in the winter to the PNA, the stratospheric polar vortex, whether it's strong or weak in the winter season. And I didn't even throw in the Madden-Julian Oscillation here, okay? Also another big driver of the weather in the winter. So it's a complex line of work that we're in here, and you can't just assume because it was cooler than average, that the winter is going to be bad. No, you can't do that because there's a lot of complexities here within this fluid of air we call the atmosphere. So I wanted to show you all the breakdown of other teleconnections in addition to just the ENSO phase in those winters following the cooler than average August. So now let's move ahead and let's examine the ENSO forecast for the 25-26 winter season. On the left here, we're showing the latest August 2025 IRI, International Research Institute, and we're showing you the general Nino 3.4 sea surface temperature anomalies in degrees Celsius. So you see on this vertical axis here, these are my temperature anomalies in degrees Celsius. How far above or below normal are my values? If I have a negative sign in front of the values, that means my water temperatures are cooler than average. And on the x-axis here at the bottom, I'm showing you increments of 3 months. So SON stands for September, October, November months. OND, October, November, December. NDJ, November, December, January. DJF, December, January, February, and so on. So now we look at all the different color lines on this graphic here on the left produced by IRI, these IRI plumes, and you notice all these different models, okay? All these lines with different colors represent different atmospheric models. So you have dynamical models, you also have statistical models, all right? So the green solid line is the average of all the statistical models, and it generally shows the water temperatures in this Nino 3.4 region running below normal, but it only gets down to about minus 0.5 degrees Celsius below normal in the months of November, December, January. And then it kind of flattens out in December, January, February, just short of minus 0.5 degrees Celsius below normal. And then it starts becoming more neutral with the average of all the models from the statistical models, the green line. This maroon line indicates the average of all the dynamical models. And so it's not even going down to La Nina territory. For La Nina, you need to have these water temperatures in the eastern and central Pacific, tropical Pacific areas to be running greater than minus 0.5 degrees Celsius below normal. And you see the maroon line here is the average of all the dynamical models. It's only going down to about minus 0.4 degrees Celsius below normal in November, December, January. Then you see slight warming of the waters in that Nino 3.4 region the rest of the winter. By the way, if these lines, these models, are ranging from positive 0.5 to negative 0.5 degrees Celsius, that is indicative of neutral ENSO conditions, okay? You can see most of the lines. Maybe we briefly touch a weak La Nina here in the beginning of winter, and then we quickly go to more ENSO neutral conditions. It's a possibility. But the majority of the winter, it's really looking like mainly an ENSO neutral winter. Well, again, we may start off with a weak La Nina briefly at the beginning, but the heart of the winter could be influenced more by North American teleconnections, as well as the Pacific phases, right? The MJO phase, the EPO, the Eastern Pacific Oscillation. But just wanted to show you what the forecast is here from IRI on the left. Weak La Nina at best, majority of the winter, and so neutral territory. Here on the right is a different way to display the probabilities of ENSO. So blue vertical bars indicate La Nina conditions. The red vertical bars indicate El Nino conditions. And then the gray vertical bars indicate ENSO neutral conditions. So right now, in the months of July, August, and September, we can clearly see this gray bar is much taller than this blue bar, right? And you see over here on this vertical axis, we have the percent chance or probability percentages here, ranging from 0 to 100%. So you can see we're right now sitting at like a 76% chance of neutral conditions right now. Now, as we get into the winter months, or later in the fall at least, we go into October, November, December. Notice the blue bar here is taller than the gray bar, which indicates that the probability is greater, almost 60% chance that La Nina will be in place in the months of October, November, December. But watch how this blue bar gets shorter and shorter and shorter. By January and February, March, we're now looking at only a 33% chance of La Nina. And by January, February, March, the gray bar is taller now. That indicates ENSO neutral, and we're looking at over a 50% chance of ENSO neutral by January, February, March. So gives you an idea of, hey, what does it look like? What's a higher probability here? La Nina or neutral conditions? It's really what it comes down to this upcoming winter. El Nino is not going to happen this winter. And then we also need to look ahead at the quasi-biennial oscillation, this QBO. Now, the QBO is basically an indicator of the wind direction over the equator. These are the winds within the stratosphere over the equator. Okay, and it regularly changes from east to west. It usually goes easterly phase one winter, the next winter will be westerly, and just repeats easterly, westerly, easterly, westerly, easterly, westerly. And so this winter, we're expecting more of a descending easterly phase of the QBO. So why do we even care about that? Well, the reanalysis record, this is from research conducted by Ellsbury, Butler, Pangs, and Magnusdottir back in June 24. This isn't that old, research. Whenever we have an easterly phase to the QBO, the reanalysis record shows that sudden stratospheric warming, breakdowns of the polar vortex can elicit impacts. So easterly QBOs are associated typically with a weaker stratospheric polar vortex. We get a weaker vortex in the stratosphere that will generally tend to result in colder Arctic air descending into the mid-latitudes more frequently than a winter, let's say, where the stratospheric polar vortex is stronger. By the way, the easterly phase of the QBO tells us that the wind direction in the stratosphere above the equator is from the east. If I were to have a westerly phase of the QBO, that would tell me that my wind direction is from the west, high up to 60,000 feet above the equator. So I just want to explain that. Additional research has shown that the easterly QBO is associated with a negative phase of the North Atlantic Oscillation. Now, the NAO is also another key part of the winter forecast because it just depends where the higher the normal heights are setting up. Generally, with a negative NAO, you get a huge blocking upper high or ridge into Greenland, up toward Greenland. Now, if it's an east-based NAO, that generally means that your highest height anomalies or the greatest blocking is going to be located closer to Greenland or maybe even east of Greenland, right? So an easterly phase of the negative NAO would give colder than normal temperatures this winter to Europe. The west-based negative North Atlantic Oscillation will have the highest than normal height anomalies as well as the ridging strongest, generally to the west of Greenland into parts of eastern Canada. By the way, I pulled the research up out of this paper titled "Sensitivity of Easterly QBOs Boreal Winter Teleconnections of Surface Impacts to Sudden Stratospheric Warmings." Now, this was published in the Journal of Climate, this one right here, the Ellsbury et al. Publication here, the research. Here's my conclusion. Here's my breakdown. Just looking at past August being below normal in temperatures for the Mid-Atlantic, and then the ENSO forecast for the following winter, just taking these two into account. I only showed you all this, the different teleconnections, the following winters, because I wanted you to really get the point. This is not a simple puzzle to put together. This is very complex. So I just went back to the conclusion and said, you know what? Let's just focus on cooler than normal past Augusts, and then the ENSO forecast the following winter. Now we know we're expecting maybe brief weak La Nina, maybe. This is not a guarantee. And then mostly an ENSO neutral winter. I'm going with mainly an ENSO neutral winter this upcoming winter season. And so if we take that into account, three distinct winter seasons stand out to me right now as potential analog years. 85-86, 96-97, and 2013-14 seem to really stand out to me. But why did I pick those three winters? Why did I choose those three out of all these winters we looked at, right? We looked at all these winters, right? All of them, okay? We looked at the precip and temperature anomalies, right? But why did I pick those winters? Why did I choose that? Well, all three of those winters featured ENSO neutral conditions. All three of them. All right. And what I'm thinking for this winter is mainly ENSO neutral conditions for the majority of the winter. Like I said, maybe we go briefly weak La Nina, but this is going to be the majority of the time. Now we look at 85, 86, the 2013-14 winter seasons. They were colder than average across the mid-Atlantic, while the 96-97 winter season was warmer than average. So now just looking at temperature anomalies alone and ENSO neutral conditions in these winters and what's forecast for this upcoming winter, the 25-26 winter, you clearly see there's a 2 in 3 chance that we have colder than average temperatures across the mid-Atlantic this upcoming winter. There's a 1 in 3 chance, or about a 33% chance of 1 in 3, that we see above normal temperatures across the mid-Atlantic this winter. Now, based on the current forecast for the mainly ENSO neutral conditions, and I also took a look at sea surface temperature anomaly forecasts, the actual values for the Nino 3.4 region, like where these values kind of range or stand out. The 85, 86, and 2013-14 winter seasons stand out as the primary analog years. I would give these two winter seasons more weight than the 96-97 winter season. And then additionally, what kind of throws out my thinking there, I kind of threw out 96-97 by just looking at the ENSO neutral conditions and the forecasted sea surface temperature anomalies in that tropical eastern and central Pacific. But there's a problem. Because the winter of 96-97 featured an easterly QBO, whereas the winters of 85-86 and 2013-14 featured a westerly QBO. So there's a slight difference here amongst these three analog winters. 2 of the 3 had westerly QBO phases. 1 of the 3, the 96-97 winter season, had an easterly QBO. Now this is not, and I'm going to say this is not an official winter forecast. It is still way too early to determine what this winter holds. I know you might see some folks on YouTube putting videos out there about the winter forecast, but even they most likely will not be correct. The reason I say that is, we're just starting September now, and a lot can change between now and early December. This whole video is simply using observed anomalous weather, the cooler than average August the cooler than average August this year, and then I'm comparing it to the weather in the following winter seasons. That's it. That's all I'm doing. Don't read too deep into it. This, by the way, is just one piece to this entire complex puzzle. But I thought it was interesting enough to make the video. Okay. All right, that's all I got for now. I'll be working on more videos here in the future. I may go back to my teleconnections videos here shortly, here in the month of September. But again, I like these type of topics. I hope you find them interesting. I certainly do. Do cooler than normal August really mean a whole lot for following winters? Looking at the data I pulled, maybe there is a connectable link there, right? Really based on this slide here I showed you, right there. No, there. This is the big takeaway for me, this slide. Okay. So the odds of a colder or near average winter versus colder than average are pretty close in the winters following cooler than average Augusts. Now, we still have 2 of the 15 past, follow-on winters after cooler Augusts that did have warmer than normal temperatures. So we can't say this with 100% certainty that just because only 2 of 15 following winters were warmer than normal, we can't get it again, because we can. But then, you look at the precip anomalies again after cooler than normal August for the following winters, and there's really not a distinct, signal here that says, oh, wow, that's a lot of winters that were near average precip, or whoa, that was a lot that were below, or a lot that were above. 6, 5, and 4 is not that great of a difference, obviously, between those winters. So But that's all I got for now, everybody. I hope you had a great Labor Day weekend, by the way. We're about to wrap that up. And I wish everybody a great, great day. Until next time, take care and God bless everyone.